Hi guys, we're in the math person, and today I'll be going over question 297 on SOA exam P. So pause the video real quick and try this problem yourself. Okay, assuming you already tried it, let's just dive right in. The question asks, the random variable x is the moment generating function m of t. Determine which of the following is the moment generating function of some random variable. Okay, so let's just take it one by one. So number what this could be, okay, something to note first is moment generating function of some x of t is equal to expected value of e of t of x, right? Okay, so then for one, when it says m of t, let's just say like this is x, and m of, let's call this x2, 5 of t1, 5 of t should be equal to the expected value of e of t of, e of t of x times expected value of e of 5t of x2. Correct? But this can also be simplified to expected value of e of t of x plus, or inside of it, we can just write e of t of x or e of 5t x2, assuming independence, which is also equal to e of t of x plus 5t x2, right? Well, then we know that this formula right here is just the MGF of some function, some random variable function, some random variable t, some random variable of x plus 5 of x2, right? So then we know that this is true because this is a moment generating function of some random variable. Okay, let's try it for 2. For 2, we have the function 2 of m of t. Well, we know from the get-go that all random variable, all moment generating function at t of 0 has to equal 1. But then if that's true, then 2 of m of 0 is equal to 2 times 1, which is 2, which is not equal to 1. So because of that, this can't be a moment generating function. So cross it off. For 3, we can think of it this way. We can set a random variable x with a probability of 0, -1 is equal to 1. Then we know that the moment generating function of this variable x is the expectation of e of negative x, right? Well, expectation of e of negative x is just probability times the probability times the actual value. So the actual value was 1 times e to the negative tx, or e to the negative x, which is just equal to e to the negative x. So thus proving that the e of negative x is indeed an MGF. So because of that, we know that the MGF times MGF is still a random variable, as demonstrated by question 1, or set problem answer 1. So we know that the 1 and 3 is both correct. If you guys have any questions, feel free to leave them down below. Otherwise, make sure you like, subscribe, and share. Bye!